Hi, everybody. For today's lesson, I guess we can call it, I am just going to go through the review assignment and not going to spend too much time doing every single problem, but I'll try to give a sampling of what these different functions look like, the different descriptions, stuff like that. Reminder that your test is on Thursday. You do not need to sign into the Google Meet unless you have questions. I will have it open. Unlike on Wednesday, there will be no Google Meet. But you should be able to go on Schoology and work on it. It is a timed test. I think the time that I've allotted is going to be sufficient for you if you are doing things the way that they're intended. If you are doing it the way that I am not intending, you may have some problem getting done, but I guess that's the reason that I put the time limit on there. First section here, we just have the parent functions. Know what those 6 look like. I've got the answer key for that assignment, the first assignment from the chapter, so I don't think I'm going to spend too much time on that right now. The second section, we're looking at identifying the parent and then figuring out what the transformations are and drawing a sketch. There's a lot going on in this one. I'm looking at these two. I think I'll do number 2, a cube function. And there's our parent function. We got x cubed is our parent. Translations, I've got x plus 6 inside the function. So that's going to move the graph to the left by 6. And then plus 2 outside of the function or after the function is going to move up 2. So for making the graph, and I apologize, this graph paper didn't come across very well. The vertical axis isn't lining up very nicely, but we will make do. I am going to take the point that would have been the center of this curve and move it to the left 1, 2, 3, 4, 5, 6, and up 2. So now there's my new center for this graph. Now for the x cubed function, if I were to graph just the regular function, I know that it is centered at the origin, and then I'm just thinking different values that I know the cubes of. I know 1 cubed is 1, so over 1, up 1. 2 cubed is 8, over 2, up 8. 3 cubed would be 27. That's way off the top of my graph. And then going backwards also. -1 cubed is -1. -2 cubed is -8. And so I'm going to be going through that same process, except as I'm doing this problem, I'm thinking of this as my center. So over 1, up 1 to get to that point. Over 2, up 1, 2, 3, 4, 5, 6, 7, 8 to get to that point. And then the same thing backwards. -1, -1, -2, -1, 2, 3, 4, 5, 6, 7, 8. And then I just play a little game of connect the dots. Now your quiz on Thursday, you won't actually be drawing these. You may be identifying which of the graphs match up. And that's probably going to be helpful for some of you. Let's see. I'm just going to see if there's another one that jumps out at me as another one that I want to do. Maybe number 6. There's a radical function. My parent is the square root of x. And then the order, the inside the function is x minus 4. So that means it's going to move to the right 4. And then usually I would have something plus 6. Here I've got 6 plus that, but we're still adding 6. That's a positive 6. And so that's going to make the graph go up by 6. So same idea on the graph. I need to think about what the square root function would look like. And my square root function, I know, starts at the origin. And then unlike this, x cubed, where I was thinking of different values that I know the cube of, I'm thinking about numbers that I know the square root of. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And then we end up with that radical shape. So as I'm graphing this one, same idea, except I'm shifting my graph to the right 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. And so now from this point, I'm thinking the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, but that's already off the edge of my graph. And so I end up with a graph that looks something like that. I know that there was at least one person specifically who wanted me to go through a couple problems like this. How do you graph a function given the equation? I do not want you to do this and to make a table of x and y values. I'm not forbidding you from doing that, but that's kind of going against the point of a problem like this one, where if I plug in 0, I get a -4 inside the radical, so I can't even do that. I can't even really graph anything until I get up to x equals 4. And when I plug in 4, I end up with the value of 6. When I plug in 5, I'll get a value of 7. And you can do this. You can play connect the dots, but again, that's kind of going against the point. So I'd rather not do this. I'd rather you think of it in terms of transformations. Cruising along the next section here, we're just identifying the parent. So we've got a bunch of different graphs. Haven't done an absolute value graph yet, so let's do that one. Not a lot of space to write here, but I've got an absolute value graph. It has been moved to the left by 3, and that vertex has been moved down 5. And again, the point that I look at to determine what these transformations are for an absolute value graph, I'm looking at the corner. For a radical graph, I'm looking at the starting point. For a cube graph, I'm looking at that wiggle point where it kind of levels off. Before it starts increasing this way or decreasing that way, I'm looking at that point. Well, maybe we'll just do that one next. My equation for this one will be y equals, of course, I've got the absolute value. The down 5 is going to be a -5. And then I'm replacing the x. To move it to the left by 3, I'll replace the x with an x plus 3. So there is the equation. As you're working on this review assignment, by all means, pull out your calculator, graph y equals this stuff, and then take a look at this window and make sure that it looks like what it should look like. But on the test, you should not be using a calculator. For the hyperbola equation, this one's a little bit trickier because I don't have a point that I can look for. The parent function of this 1 over x graph, I know that it looks like this, but there's no point at the origin that I can look at. And so when I'm doing the hyperbolic graph 1 over x, I guess I can acknowledge that is my parent function. To figure out what transformations are happening, I'm going to think about the asymptotes. The asymptote was the y-axis. Now it looks like the asymptote is at -5, which means this must have moved to the left by 5. And then horizontal asymptote usually is the x-axis. Looks like we're down here at x equals -1. It's approaching -1 from the top, approaching from the bottom. So this graph must have moved down by 1. And then my equation, let's see, the down 1 is always the easy part for me to take care of. It'd be nice if you could see what I was doing there. So 1 over something, -1 is going to move it down 1. And then to move it to the left by 5, I'll replace the x with an x plus 5. Let's see. 13 is kind of an interesting one because we just have a line. And so my parent function is just y equals x, but then my transformation could be a couple different things. This could be y equals x moved down 3. Or maybe you could think of this as y equals, and I'll replace the x. If I want to move it to the right 3, I could replace that x with an x minus 3. But of course, we get the same thing both ways. Or maybe I could take that point that was at the origin, and maybe I think of this as my new translated point. So I could think of it as, let's see, move it to the right by 1. I'll replace the x with an x minus 1, and then move that point down 2. But we're getting the same thing. X minus 1 minus 2 is the same as x minus 3. So different ways of thinking of it, but we end up getting the same result in any case. As I'm looking at the rest of these, maybe number 14, cubes are a little bit tricky. But as I'm looking at this function, I'm looking for the point that is the translation from the point that was 0, 0. I'm looking right about there. again, where that wiggle is leveling out. It's increasing pretty sharply and it levels out, and then it starts to increase more quickly. And that point, well, it's called an inflection point. We'll talk more about that later, but the best way I can describe it is where the wiggle is changing, where it changes from slowing down to speeding up, I guess. Anyway, my function, my parent function is x cubed. My transformations, this point that was at the origin is to the left by 7 and down by 5. Which means my equation will be, run out of space here. Let's see, to move it to the left by 7, I'll replace that x with an x plus 7. To move it down 5, we'll go minus 5. Now, that's probably enough of those graphing problems. And then I believe the last section here, we've got part 4. And all we're doing here is writing an equation. We've kind of already done that in terms of graphs, but now we're just looking at, here's the information. I want to take an x squared graph, translate it 10 right and up 6. So to translate 10 to the right, we'll replace the x in my equation with an x minus 10. To move it up 6, we tack on a plus 6 at the very end. I'm looking at the rest of these, trying to see if there's one that I haven't done. I think we've done at least one of each type of function. Maybe I'll just look at 19, the radical. I'm replacing the x. If I want to move it 4 to the right, I'll replace that x with an x minus 4. Down 3 is accomplished with the minus 3. And then maybe one of these hyperbolas, something like this one, 1 over x. Well, we've got one that's going left, one that's going down. Let's just do both of these quick. Translating 9 to the left, just replace that x with an x plus 9. That's it. For 21, moving it down 3, so y equals the function minus 3. And if I wanted to combine these two and do both at the same time, well, we've already seen what's happening. Replace the x with an x plus 9, tack a minus 3 on the end. I've got y equals 1 over x plus 9 minus 3. And that would be the hyperbolic graph of 1 over x moved to the left by 9 and down 3. Okay, so fairly quick, just about 13 minutes there. If you have any additional questions, certainly get in touch with me, let me know. Otherwise, good luck on the test on Thursday. I'll have the Google meeting open for you if you have any questions. But good luck, and we'll see you later. Bye-bye.